Good day! Our topic for today is about the derivative of the function as a slope predictor formula. Last meeting we discussed about the limit concept, wherein we started discussing the tangent line problem, because the tangent line problem as well as the limit concept lead to the derivative of the given function. So we recall first what is a tangent line problem. Tangent line problem. Okay, suppose we are given the function y is equal to x squared. So what's the graph of y is equal to x squared? It's a parabola opening upward. So the graph looks like this. Okay, suppose this is y is equal to x squared. Okay, and suppose this point of the graph is A. This is A. So if this is A and we have the function x squared, what's the function value? If this is A, this is A squared, right? Because the value of the x, the value of our x here, the input value is A. So if we're going to input A here in the function, it becomes A squared. Suppose this point, we call this one as point P. Okay, now we pick another point in the graph. Let's say point Q. Okay, now point Q, so if suppose the x coordinate here is x, then the function value is x squared. Okay? Okay. Now from the 2 points in the graph, we can form a secant line. The secant line, we call the secant line, let's say, secant line K. Okay? Now, the problem, the tangent line problem states that if we are going to solve the slope of the tangent line, the slope of this tangent line at point P, how can we solve it? Okay? How can we solve, let's say this point, this line is L. Tangent line L at a point P with a coordinate A and A squared. Now take note, it is very hard to directly compute the slope of the tangent line using only one point. But because of the secant line, we can compute the slope of the tangent line. Take note, here from point P to Q, we can form a right triangle. We can form a right triangle, right? So, from the right triangle, we can now compute the slope of the secant line. What's the slope of the secant line? Take note, this is delta y. What is delta y? It's the change of y. And this is delta x. Okay? Delta y and delta x. Delta x, take note, this is x, x. Okay. Now, delta y is the change of y, and delta x is the change of x. Now, if we use the notation, if delta x, we equate this one as h, meaning to say the delta x is the change of x, we use another notation that is h. Now, the slope of the secant line, that is slope of the secant line, is actually what? The delta y over delta x. Delta y over delta x. Okay? What's the delta y? What's the delta y? So the delta y change of y over delta x, that is actually the slope of the secant line. Now, since delta x, we let delta x to be our h. In other words, x is equal to what? In terms of h, x becomes a plus h. right? Or a plus delta x. But since delta x is equal to h, therefore x is equal to a plus h. So in other words, we already have the formula for the slope of the secant line, that is delta y over delta x. But take note, the problem is to compute the slope of the tangent line L. How can we compute that one? We have to compute first the slope of the secant line. What is delta y? The delta y is actually what? Delta y, change of y. So we have 2 points. Delta y is x squared minus the first y, this is a squared. What is delta x? The delta x, this is x, what? X minus a. Okay? Change of x, x minus a. Okay? Now, since from here, we can write this formula in terms of h, because we write x, which is equal to a plus h, where h here is actually the change of x. So, since x is equal to a plus h, this can be replaced by a plus h. So, this becomes a plus h squared minus a squared over a plus h minus a. So, this becomes a squared plus 2ah plus h squared minus a squared over h. Why h? Because this will be cancelled out. A minus a. So, this will be cancelled. This becomes 2a h plus h squared over h. Take note, h is a common factor to these two terms and also the term in the denominator. So, we can factor this out. H, 2a plus h over h. So, this becomes what? This is the slope becomes 2a plus h, which is actually the slope of the secant line PQ. Right? So, we already have the formula for the slope of the secant line PQ. Now, during our discussion with limit, getting the limit of the slope of the secant line is actually the slope of the tangent line. So, in other words, getting the limit of the slope of the secant line PQ as h approaches 0, that is equal to the limit of 2a plus h. As h approaches 0, this is equal to what? Since this is linear, so this is 2a. This is actually the slope of the secant line PQ is actually what? The slope of the tangent line at a point what? At a point, at a point A. A, f of A. Okay? So the slope of this secant line. Now, so this is m of A. So we can have the notation as the slope of the tangent line. M of A is equal to 2a, which is actually the limit of the slope of the secant line. Now, we have to take note, if we go back to this formula, this is actually, if we go back to this formula here, since x is equal to a plus h, this is actually our f of x plus h, right? Why? Because we substituted a plus h to our function x squared. So this is f of x plus h minus f of what? By the way, since a is a value, so this is f of a plus h minus f of a over h, right? So, that's the what? This is the slope of the secant line. Now, getting the limit of this, that is limit of the slope of the secant line as h approaches 0, this is actually the formula of the slope. The slope of the tangent line at a point A, f of A. Okay? So that is the slope of the tangent line at a point A of f of A. Now, what's interesting here is the slope of the tangent line at the point A f of A is actually the derivative of the function at the point A f of A. So we have here the definition of the derivative, which is actually like that.